Hello and welcome to another video training tutorial from Epic Games. In this video we're going to show you how to create this little conveyor belt system that you're looking at here, which is trying to move these boxes down the conveyor. Of course, in this case some of them are falling over the edges. Now our focus is just going to be on the conveyor system, which is very simple, and when we get done, as an added bonus, I'll show you how we're spawning all these boxes into the level as well. So let's go ahead and get started. I'm going to stop simulating and we'll delete out all these pieces of the scene that we don't really need right now, because we're going to be making all of these from scratch. So here inside the content browser, let's start by making a new folder to keep everything organized. So we'll right click and choose new folder, and I'll call this My Conveyor. And we'll open this up. Now inside, I want you to create a new blueprint. So just right click here in an open area and choose Blueprint Class. From the Pick Parent Class window that appears, you want to choose Actor, which is anything that can be placed in your scene. We're going to name this My Conveyor Volume. And then we'll double click it to open it up inside the blueprint editor. Now this object is really only going to need a couple of very simple components. So we'll start by adding a box collision component like so. And we're also going to add an arrow component. And the arrow component is really just here to help us see what direction objects are going to move along the conveyor. Now the names for these are actually descriptive enough. We don't need to change them, so I'm not going to bother with that. I am going to do one little thing just for vanity's sake. And let me show you what it is and kind of why. If I compile this and go into our scene, and then I drag a copy of it into our world, obviously we're going to want our volume, the area that's moving objects, to be a little bigger. So if I start to scale this up, you'll notice that my arrow gets scaled up as well. And that's okay, but it's kind of annoying for me because I might be using some really weird or very stretched out conveyor volumes. So what I'm going to do is set this up so that no matter how I scale that box, the arrow remains the same size. And here's how we do that. First, over here in my component list, we can drag a reference from the arrow right into the scene. So now we're talking to that arrow. We're going to drag a blue wire off of that and choose Set Relative Scale 3D. We can plug that in. Now the question becomes, what are we going to set that scale to? Well, we're going to start by getting the actor's scale. So as we scale up the actor in the viewport, we're going to get that scale. Then right click here in space and choose Vector divided by Vector. We're going to plug the Get Actor Scale 3D node into the second pin. And the first pin we're going to set manually to 1, 1, and 1. We'll plug that into our new scale 3D. If we compile that and take a look here in our viewport, notice that that red arrow remains the same size no matter what we do to scale up the box, which is super convenient. So that's how we're going to have that set up. Now over in the event graph, this is where we're going to do all of the magic. This is what's going to make our conveyor system do its job. Now we're going to be basing everything on the tick event. As a warning, you should generally be careful about using the tick event because it has to fire on every frame of your game. So you don't want to put anything in here that's going to be super costly to perform. Just something to be aware of. I'm going to right click out here in space. Actually, let me not do that. Let me click on my box component over here inside the My Blueprint tab. And with that selected, I can right click and choose, just start typing the word overlapping. And you'll see there's an option here for get overlapping actors that are within the box. So really, this is going to churn out a list of everything that is currently inside that volume, which is super convenient. Now we're going to drag a wire out from this, because this is giving us an array. It's literally a list of everything inside that volume. And we're going to do a for each loop on this. This allows us to perform some sort of functionality on every single thing that is inside this list. So we'll connect this up to tick, and now the question simply becomes, what is it we want to do? Well, we're going to take each element, each thing in the list, and we're going to add a world offset to it. So we're going to literally push it in some world direction, and we need to plug that up to the loop body. Now the real question becomes, what is the delta or the changed location? How far are we going to move this thing? And because we're doing this based off of tick, we want time to be a factor. That way, if the game starts to get laggy for any reason, we don't end up with the amount of motion changing very much. Now the way we're going to handle that is we are going to take delta seconds off of our tick event, and we are going to multiply it by something. So we'll choose float times float. And for our other number here, we're going to right-click on this lower pin and choose Promote to Variable and name this variable Speed. Because now that we are multiplying this by delta seconds, which is literally how many or how much of a second, how much of a fraction of a second is taking place in between each frame, by multiplying these numbers together, we are able to calculate speed in units per second. So now that we have that, we now know how far we want the object to move. We just have to turn this into a vector, into something with direction. To do that, we're going to right-click and choose Get Actor Rotation. So this returns a rotator, which represents the rotation we've applied to that box in our viewport. And we're going to drag a wire off this and choose Get Forward Vector. So now we've defined a vector, which is literally forward based off of that rotation, and we're going to multiply this by a float. And we're going to end up multiplying it by this speed value, take the end result and plug that into our delta location. We're technically done at this point. The last thing we need to do is compile, make sure we select this speed and give it a nice default value. In this case, let's do 200 units per second, and let's compile and we'll save. Now, let's make sure we set this right on top of the ground. Now, we won't be able to see it by default, so let's fix that. It'll only take a moment. We'll jump back inside our blueprint, and if we select our box component, I'm going to temporarily turn off Hidden in-game. It's under the rendering category, and it just means that when we play the game, we'll be able to see this box. So let's hit play. And actually, I'm simulating, so let's make sure I'm actually playing in the selected viewport. And if we stand in the conveyor, you see we start to slide along. And I can even fight it if I want to. I can run up the conveyor, and it'll keep sliding down. Now granted, if you wanted this to look like a conveyor belt, at this point you'd want to create some sort of a mesh that had a panning texture that looked like a conveyor. But for all intents and purposes, this is actually working. So we are kind of done, but I'm going to take a moment and I'm going to set up a really simple scene that shows how this is working. So let's rotate it 180 degrees, and we're going to set it really close to our stairway over here so our character can get to it. And then over in my placement browser, I'm going to drag in a cube, and let's line this cube up. So the cube will kind of represent the model of our conveyor belt itself. We'll kind of scale it up so it's about the same size. It doesn't have to be perfect. We do, however, want this volume to sit just above the surface of our conveyor, or above the actual mesh itself. You also notice I'm having kind of a fun time selecting this object. It might be a good idea to add something like a billboard component at some point to make it easier to select. So let's scale this out a little bit because we want a little bit of overhang so that objects can fall off the edge once they hit that. You'll also notice I'm going to set this right above the surface so it's just barely sticking up over the top of the box. Now I'm going to drag in another cube, which will move up into the air, and this is just how we're going to test this. With this new cube selected, let's turn on Simulate Physics. Also, make sure you scroll down under Collision and check Generate Overlap Events, like so. So now if I simulate, it lands on the conveyor and slides along, and everything's great. Now, we also kind of want to make sure that we can't get snagged, because you'll notice he was still kind of passing through the conveyor volume there at the very end, which is really no good. So let's go ahead and stop simulating. And let's take the whole contraption. So we'll take our volume and the mesh itself. We'll lift these up into the air. And then maybe we'll just take our volume and scale it down just a little bit, so it's a little bit thinner. And if we simulate again, perfect. And we fall off the edge. Okay, so that's working out pretty well. I guess now the only other thing, and this is just because I told you I would, let's make a quick system to throw some random boxes down. Now I'm going to do this fairly quickly because this is not really the focus of the video. Let's right-click in the content browser and I'll make a new blueprint class. I'm going to base this off of actor, like so, and we'll call this conveyor box. We'll double-click to open this up in the blueprint editor, and all I'm going to add to this is a cube, like so. Now in the event graph, I'm sorry, not the event graph, let's go to the construction script. We're going to take this cube and let's drag out a reference to it, and we're going to set its relative scale 3D. Now, the new scale 3D pin, we're going to right click on that and split the struct pin. So now we have individual access to X, Y, and Z. Let's drag a wire off of X, and we're going to choose random float in range. And we'll do a minimum of 0.3 and a maximum of 1.3. I'm going to hit Control C and then Control V and paste that in, and Control V and paste it in again. And we'll plug that into Y and plug it into Z as well. So now what we've done here is we've created a blueprint that spawns in a box that is always going to have a random size applied to it. So let's make sure we compile that. And now you'll notice as I move it around, it keeps getting a random size. Always changing. Now that is not going to change while the object moves through. It's only going to change the moment the object is born. So now the last thing we need is to create the spawner, the thing that is going to keep popping these into the world. So let's right-click and make a new blueprint class based on actor once again, and we'll call this box spawner. We'll double-click and open this up. And then let's add a billboard component. This is just some visual way for us to know where this object is going to be placed in space. It's not going to do anything else in and of that. So let's go to the event graph. And we're going to do a couple of things. We're going to use begin play, and then we're going to create a custom event. So right-click in space and choose custom event. And we're going to call this spawn box. Now, what is spawn box going to do? Well, very simply, it is going to spawn an actor from class, like so. And we get to choose the class from a dropdown, and you're going to choose conveyor box, the one we just created a moment ago. Now, this needs a transform, so what we're going to do is take the transform, right-click it, and split it. And you can see what makes up a transform. It's location, rotation, and scale. All I really care about is location. So we're going to right-click and choose Get Actor Location and plug that in. What this says is we're going to spawn this box at the location of our little spawner here. Now for rotation, let's be a little fancier. We're going to drag a wire off of this and choose Random Rotator. And we'll also randomize roll. Now we just need some way to fire off the spawn box event. We're going to do that with a timer. So here on begin play, let's drag out a wire and we will say set timer. Now, this requires a function name. The function name is going to be spawn box. So it'll be calling this custom event that we just created. How often do we want it to call? Let's call it every half a second, and we'll set it to loop. So it's just going to keep calling spawn box every 5 seconds as long as the game is playing. So we'll compile, we'll save that, let's jump back out to our map. Now we can bring out the box spawner and we'll move it up into the air and simulate. And we're not actually doing anything because our boxes are not simulating physics. So it's a quick fix. Let's grab our conveyor box blueprint that we just created, double click it and select your cube component that you added a moment ago and make sure that you check simulate physics. Because if you don't, obviously it doesn't simulate physics, which is bad. So now let's simulate again. And there we go. They're falling. They're landing on the conveyor. And they're being moved with all due diligence toward the end and then falling off. Really, we're done. The only thing I might do at this point is grab my conveyor box blueprint, and if you take a look inside of its class defaults, I might give it an initial lifespan of about 10 seconds. That way we don't just keep filling the scene up, and eventually they will die off. So that wraps up this video. We've actually taken a look at several different things. We showed how to create this sort of conveyor style effect. Again, this would warrant an art pass at this point. You'd make a mesh that looked like a conveyor belt. That mesh would have a texture on it that panned, to look like the conveyor. You'd probably have to make sure you had that panning rate and the motion of the boxes in sync, but that should be easy enough to set up. We also took a look at how you can spawn objects in the game repeatedly based off of a timer and blueprint. So that's going to wrap things up for this video. Thanks for watching.